All right, guys, 2018 free response problem number 6. We've been given a differential equation right up here, and that's really all the info they gave us at the beginning right here. They've given you the slope field, which was nice. We didn't have to draw it, and two things they wanted us to do right here. Sketch two different solution curves, one that passes through the point 0, 2. This is about the easiest point I've ever seen on an AP free response question. That solution curve is going to start at the point 0, 2, and you can see here that there's a series of horizontal tangent segments here going through that point. The word we used for that back in the day, everybody, was called an isocline. I said that was not a word you needed to know, and you still don't, but basically it works like a horizontal asymptote, and in this case, the solution curve through the point 0, 2 is simply a horizontal line. That's all you had to draw for that one. The second thing they wanted was the solution curve that passes through the point 1, 0. So starting at this point right over here, remember what we're doing with a solution curve is think about dropping a bag or something really small in the wind and look at this as a wind map and just think about where this thing is going to go. The slope here at the point 1, 0 looks like it's about 1 going in that direction right there. So we're just going to follow this thing up. And now as we move from left to right, it looks like that slope is leveling off a little bit more. And in fact, if we do in fact look at that isocline as a horizontal asymptote, our curve is going to get closer and closer to that, but never quite hit it as x moves out to the right. Now moving from right to left now from that point, we're going down a little bit here, but that slope is kind of leveling out a little bit. And we can see here that as any solution curve crosses through the y-axis, the slope is actually going to be 0 or perfectly horizontal at that spot. And then, as we move further to the left, this thing now goes upwards in this upper left direction. And now we start to see the exact same thing happening over here on the left that we saw on the right, that it continues to increase, moving from right to left. But with that isocline, it again is acting as a horizontal asymptote. And our solution curve there is going to be much more interesting than the initial was, passing through 0, 2. And this one through 1, 0 is going to look like that. Okay, so that's it for part A. All right, so for part B, they've said let f of x be the particular solution to that diffie q with an initial condition right here of f of 1 equal to 0, and we want to come up with an equation for a tangent line to the curve at that spot. And then a second question now, here's your equation to approximate f of 0.7. Very easy to come up with the equation and then miss the second part of that question. So let's take a look at what's going on in part B. So here's the differential equation. Oops, sorry about that. Here's the differential equation that we were given. And then for B, there's our initial condition that f of 1 is equal to 0. So just try to keep fundamentals in mind here. If we're trying to come up with the equation of a tangent line, there's two things that we need to know. One of them is your point of tangency, and that was given to us right here by the initial condition. So 1, 0 is the point of tangency, and that is one of the two things that we needed to know. The other thing we need for the equation of any line is the slope of the tangent, and that comes from our derivative, which we were given right here in this problem, evaluated at the point of tangency. So, using a good Leibniz notation here, we're doing dy dx evaluated at the ordered pair of 1, 0, and in that derivative, everywhere there was an x, we replace it with a 1, and where there was a y, we replace it with a 0. And that's going to get us 4/3 now. So what we have right there, 4/3, is the slope of our tangent. Okay, so those are the two things we needed. I went ahead and put that together now into point slope form. A y minus 0 equals 4/3 times x minus 1. And with that minus 0, it was pretty easy to solve that for y. You really didn't need to distribute the 4/3 there, but I did. And that there is what they were looking for the equation of the line tangent to the graph. So that's the first part of B that they wanted. The second part was to ask us to use that equation to approximate the value of f of 7. All right, so this is the concept of linearization right here. So we're going to go ahead and take this equation and we're going to put in a 0.7 for x. So f of 0.7 would be approximately equal to, and now you guys know I don't like the mixed metaphor here of using a fraction and a decimal value right here, so I went ahead and changed the 0.7 into a fraction of 7/10 minus the 4/3. That was a 28 over 30 or a 14 over 15. I changed the 4/3 into a 20 over 15. That became a negative 6 over 15. and negative 2/5 was the answer that I came up with. I believe on their standards they had a negative 0.4, and last I checked, those two things are equal to each other, and of course they're going to give you full credit for either one of those since those are mathematically equivalent. Okay, and the last part here, part C, asked us to find a particular solution, y equals f of x, to the given differential equation with an initial condition. So as soon as you see the words differential equation and initial condition, we know that we are dealing with an initial value problem, and that shouldn't surprise us to see these on here. Those show up with some regularity. So let's take a look at what's going on right here in part C. So the first step right here was to separate our variables from the original differential equation. So let's see what we can slide down here a little bit for you. All right, so for part C, all right, here we go, everybody. So that y minus 2 quantity squared on the right needed to be moved over here to the left. So I went ahead and divided both sides by that, putting the y minus 2 squared on the bottom of a fraction. The 1/3 and the x stayed where they were, and the dx came to the right side. So that right there is the full and complete separation of variables, and once we've done that, it was time to go ahead and anti-differentiate the left and the right at the same time. Now I didn't write this out, but remember that this is y minus 2 to the negative second power. Anti-differentiating that, we'd raise the exponent by 1 to negative 1, and then divide by that negative 1. So that's how we got a negative 1 over a y minus 2 on that left-hand side. Equals this x, power increases to become x squared. We divide the 1/3 by 2, and we got a 1/6 x squared and a plus c. Now's a good time to kind of indent a little bit and work to find the value of c by using our initial condition, which was the ordered pair 1, 0 we had used earlier in this problem. So by putting a 0 in for y right here and a 1 in for x, we got this expression. Negative 1 over a 0 minus 2 became a 1/2 is equal to a 1/6 plus c. Subtracted the 1/6 from each side, and the 1/2 minus the 1/6 got us 2/6 or 1/3. So there was the value of c, and we knew that. So now we're going to go back to where we were just a moment ago, right up here, but now we're going to replace that c that we had there with this new c value of 1/3. So this is where we were right now. What happens next isn't always an option, but it worked here, and if you can do it, you probably should. These two terms were not that difficult to combine into one by making a common denominator of 6. So we rewrote that now as a negative 1 over y minus 2 is equal to an x squared plus 2 all over 6. And then from there, what I did, kind of two things at once right here, I reciprocated both sides of the fraction and also then took the opposite of both sides. So slide this up here just a little bit. All right, so flipping the left side gave me a y minus 2 over negative 1, but I took the opposite over here, and I reciprocated the right side and made the opposite of that also. So that was a negative 6 over x squared plus 2, and then all we had left to do was to add the 2 to both sides and got y is equal to a 2 minus 6 over x squared plus 2.